Hi there, in this video I'm going to explain the compound transform. Okay, so let me explain what I mean by the compound angle transform or the compound transform. Let's take a red pen, underline this. So in this case I'll show you how to write an expression of the type a sine theta plus or minus b cos theta. And I'll show you how to write that in the form r sine theta plus or minus alpha. And let me make another bullet point. If you have an expression of the type a cos theta plus or minus b sine theta, I'll show you how to write that of the type or that of the form r cos theta minus or plus alpha. Okay, so in either of these forms, r and alpha, so let me give you the idea of r and alpha. R is a value greater than 0, and alpha is an acute angle, so it's an angle between 0 and 90 degrees. Okay? So let me show you how to transform expressions such as these on the left into its corresponding forms. Okay? The idea over here is for me to learn this, okay, if it starts with a sine, this expression starts with a sine theta, the corresponding form will be an r sine, and according to the compound angle formula for sine a plus b, if you have a plus on the left, plus relates to a plus on the right. Okay. Similarly, for the second bullet point, it starts with a cos theta, so the corresponding form will be an r cos. However, according to the compound angle form for cos a plus or minus b, the plus on the left corresponds to a minus on the right, and the minus on the left corresponds to the plus on the right. So these signs are a consequence of the compound angle formulae for sine and cos. Okay, so let me take a red pen just to highlight that, something for you to learn and note. Okay, and let me show you how to transform expressions such as those on the left to the corresponding forms on the right. Firstly, let's take an example, example 1. So let me underline this. So with example number 1, we're going to express, so question is to express 5 sine x plus 3 cos x, okay, in the form r sine x plus alpha, and r is a value greater than 0, and alpha is an angle between 90 degrees and 0 degrees. Okay, so let me show you the steps involved. Now, let me show you how to do this question. So in step number 1, so I'll call this step number 1, I'm going to let the expression in question 5 sine x plus 3 cos x, and we need to rewrite that in the form r sine x plus alpha. So the form is given to us in the question. If it's not given, remember my tip, if it starts with a sine and if there's a plus in the middle, the corresponding form will be an r sine, and the plus relates to a plus over here according to the compound angle identity sine a plus b. Okay, just in case if you haven't been given the appropriate form. Okay, so that is step number 1. In step number 2, so let's call this step number 2. Step number 2 is to use the compound angle formula for sine a plus b and rewrite the right hand side. So we're going to use the formula for sine a plus b, or the identity for sine a plus b, and rewrite the right hand term. So remember the formula for sine a plus b. The form is sine a cos B plus cos A sine B. Let me make that note as a side calculation, okay? And purely by comparison, my A is going to be x, and my B by comparison is alpha. So A, x, B, alpha. If I do the replacement over here, okay, we're going to have, so going back to the equation here, 5 sine x plus 3 cos x, so this is the term on the left hand side, that is equal to, now I like to keep the r outside and open a square bracket. So let me open up a square bracket and let me use this identity with A as x and B as alpha. So looking at the right hand side, we're going to have sine A, which is x, cos B, which is alpha, plus cos A, which is x, sine B, which is alpha. Okay, so that completes step number 2. Let me explain the next step, step number 3. So in the next step, what I do is I equate the coefficients of sine x first, because sine x appears first on the left hand side. So I equate the coefficients of sine x on both sides and cos x later, as that appears second or on the left hand side of the expression. Okay, let me write down the step though. So by equating coefficients of, so sine x first and cos x later on both sides. So if I start off with sine x, as that term appears first on the left hand side, coefficient of sine is 5, and that is equal to coefficient of sine x on the right hand side is r cos alpha, and I'll name that equation number 1. Okay, now if I do the same with cos x, coefficient on the left is 3 rather, so 3 on the left. Coefficient of cos x on the right is r sine alpha. Let me name that equation 2. Okay, now that is step number 3. Let me explain step number 4. Now in step number 4, let me show you how to work out alpha first. So in step number 4, divide your equations and divide in the order of the sine equation over the cos equation. So in other words, I'm going to divide 2 by 1 so that I have a sine over a cos. Okay, so let me divide equation 2 by 1. The reason for dividing in the order sine over cos is, sine over cos, remember, is tan. Okay, so that is the reason for dividing in the way sine over a cos. So on the left hand side, 2 over 1 is 3 over 5. And on the right hand side, 2 over 1 is r sine alpha over r cos alpha. R should cancel in this stage, and sine over cos is tan alpha. Okay, so let me continue on a fresh page. So we have the equation now. Tan alpha is equal to 3 over 5. That implies alpha is the inverse tan of 3 over 5. Okay, so in this case, if you work out the inverse tan of 3 over 5, let's have a look. I have my calculator over here. So inverse tan 3 over 5, we should have 31 degrees. Okay, and just as a double check, when you work out alpha, remember, alpha is a value or an angle between 0 and 90 degrees. So that is a good double check of your angle for alpha. Okay, so in this case, let's continue. So that is how you work out alpha. In step number 5, the next step, let me show you how to calculate R. To work out R, what I normally do is I first square these two equations. So I square equation 1 on both sides and I square equation 2 on both sides. Let me write down that step. So in step 5, by squaring equations 1 and 2 on both sides. So if I remind myself, equation 1 is 5 is equal to r cos alpha, and if I square on both sides, 5 squared is 25, and that is equal to r squared cos squared alpha. Okay, so first equation, 25, that is r squared cos squared alpha. Let me name that equation 3. And if I remind myself again, second equation, if I square on both sides, 3 squared is 9, that is equal to r squared sine squared alpha. So 3 squared 9, that is r squared sine squared alpha. Let me call that equation 4. Okay, so that is step number 5. Now, there's a reason for these steps, and let me explain the reason for squaring. The reason for squaring, firstly, is when I add these equations together, and remember the identity, the Pythagorean fundamental identity, cos squared plus sine squared gives you 1. So that is the main reason for me squaring these equations, so squaring equation 1 and 2 on both sides, because when I add in step 6, so if I calculate equation 3 plus equation number 4, on the left hand side, 25 plus 9 is 34, and that is equal to, and let me add on the right hand side, and let me also take a common factor of r squared, leaving me with a cos squared plus a sine squared alpha within the bracket. Okay, so I've added it, and at the same time I've extracted a common factor of r squared. And bearing in mind, cos squared alpha plus sine squared alpha is equal to 1. So that will give me r squared is equal to 34. R therefore is the square root of 34. And bearing in mind, r is a value greater than 0, remember. Okay? So that is how you would work out r. And once you've worked out r and once you've worked out alpha, let me just conclude by replacing the r and alpha in this very first equation here in step 1. Okay? So therefore, 5 sine x plus 3 cos x, that is equal to r is square root of 34, sine of x plus, and alpha, we work that out to be 31 degrees. Okay? So that completes this example here, example number 1, and here are the steps involved in order to write expressions of this type in its corresponding form. Okay? So here are the steps involved. Let me continue on the reverse, and let me call this example number 2. So example number 2 is we're going to express 5 cos x minus 4 sin x in the form r cos x plus alpha, r is a value greater than 0, and alpha is an angle between 90 and 0 degrees. So let's go over this one. So let's remind ourselves of the steps. So step 1 is to take your expression and equate it to the form that you need to write it in. Okay, so in this case, in step number 1, we're taking this expression 5 cos x minus 4 sin x, and we need to write it as r cos x plus alpha. Okay, so again, in this question you've been given the form. However, if you haven't been given the form, since it starts with a cos, it's going to be an r cos, and a minus on the left corresponds to a plus here on the right, and that all comes from the compound angle formula for cos A plus or minus B. Okay, because cos A plus B gives you the minus, okay, sign. So that is step number 1. In step number 2, okay, let's use the compound angle formula or identity for cos A plus B to rewrite the right hand side. So remember, let me make a note to remind you, cos A plus B has the form cos A cos B minus, so be careful, so plus on the left corresponds to a minus on the right, sin A sin B. Now if we make a comparison, A is x, and taking a green pen, B is alpha. So let me make a note, A is x, B is alpha. So if I rewrite this equation, so on the left, 5 cos x minus 4 sin x, and that is equal to, okay, so remember in the last example, so let me remind you, when it comes to step 2, keep the r outside and open up a square bracket and use the identity accordingly. Okay, so I'm going to take the r outside, open up a square bracket, and using this identity on the right hand side with A as x and B as alpha, we're going to have cos A, which is cos x, cos B, which is cos alpha, minus sin A, which is sin x, sin B, which is sin alpha. Close the square bracket. Okay, so that completes step number 2. Let's have a look at step number 3. Remember, in the last example, step number 3 is to equate the coefficients of whatever the first term is and whatever the second term is later on both sides. So looking at step number 2, the first term is cos, so we need to equate the coefficients of cos x first, and then we'll equate the coefficients of sin x later. So by equating coefficients of cos x and sin x on both sides. So let me start off by equating the coefficients of cos x on both sides. So on the left hand side, the coefficient of cos x is 5, and that is equal to, on the right hand side, the coefficient of cos x is r cos alpha. Let's call that equation number 1. Okay? Now, if I continue, let's do the same with sin x. So, coefficient of sin x is 4. You can include the minus, so you can include minus 4 over here, because if you equate the coefficient of sin x on the right, it will be minus r sin alpha. But you can ignore the minuses, so you can ignore the signs, since the sign here should match the sign over here. So they should match when you apply your identity. So whatever sign you have over here should match the sign that you have over here. So you can just as well ignore the signs when you equate coefficients, or it doesn't really matter, you can include the sign. So you can write -4 over here, because the coefficient of sine x on the right will be minus r sine alpha. Okay. However, I'm going to ignore the signs as they should be the same. So on the right hand side, coefficient of sine x, r sine alpha. Let's name that equation 2. Okay. So that takes us to the next step, step 4. So remember, step 4 is we need to divide in the order sine over cos. Okay. So looking at my two equations, I'm going to divide in that case 2 by 1. So divide equation 2 by 1. So on the left hand side, when I divide, I'll have 4 over 5. And that's equal to, on the right hand side, I'll have r sine alpha divided by r cos alpha. And as I said in the last example, when you divide, the r's should cancel, okay? And sine over cos, this is the reason for why we divide. Sine over cos gives us tan alpha. And alpha will be the inverse tan of 4 over 5. Okay? So when you take out when you calculate the inverse tan of 4 over 5, you should get 38.7 degrees. And remember, at this stage, it's good to have this in your mind. Your angle for alpha should lie between 0 and 90, and indeed it does. Okay? So that is how you'd work out alpha. Now, let me continue further. So next step, step number 5. So let's go back to the previous example. Remember, step number 5, we squared the equations, and then in step number 6, the next step, we've added them. Okay, so let's follow the same idea here. So by squaring equations 1 and 2, so let's remind ourselves, equation 1 reads 5 is equal to r cos alpha. So if I square on both sides, 5 squared, 25, that is equal to r squared cos squared alpha. So 25 is equal to r squared cos squared alpha. Let me call that equation 3. And let's remind ourselves again. Equation 2, when I square on both sides, 4 squared, 16, that is r squared sine squared alpha. So 4 squared is 16, r squared sine squared alpha. Let's name that equation 4. And remember the idea for us squaring, we square because when we add, cos squared plus sine squared alpha is 1, according to the fundamental Pythagorean identity. So in step 6, let's calculate equation 3 plus equation number 4. Okay, so if I calculate 3 plus 4 on the left hand side, 25 plus 16 is 41, and that is equal to, when I add the right hand side, taking an r squared as a common factor, leaves me with the cos squared plus sine squared alpha, and this is 1 according to the identity. So r therefore is the root of 41, bearing in mind r is a value greater than 0. Okay? So just to conclude, let's replace the r and the alpha, which was 38.7, into the initial equation that we had. Okay? So therefore, 5 cos x minus 4 sine x is the same as r being root 41 cos x plus and alpha is 38.7 degrees. So that completes this example. Okay. So once again, here are the steps involved in order to do questions like these. Okay. And sadly, that ends this video. So I hope you found this video helpful. I hope you enjoyed this video. If you did enjoy the video, a like would be very much appreciated. Do practice related questions, and I hope to see you soon. Thank you.